this is a book uh,
Uh-huh.
uh, which already has been shared by link of which has already been shared by Manoj. And the first chapter is sort of some general knowledge about deep learning, right?
Okay.
And I'm skipping first chapter because people, we can just watch some YouTube video 5-10 minutes and we will come to know about general knowledge of it and history of it. Okay. So what the
Sure.
approach we are taking is, because we already know a bit about statistics, a bit about machine learning, a bit about data science. I'm starting with chapter number second, right? And I know, as I have gone through a bit through the books, that as we go through the chapters, things will become much more interesting and clearer, because it is a sort of hands-on book, Python and everything. Okay, so we'll get to know
Okay.
things. Okay, so we'll run. So okay, so we will start with a data set, right? And the data set is MNIST data set. You heard of this data set? You or Manoj?
No, not me. Looks
Anyone?
like Ruby Kumari has joined. Hi, Ruby Kumari.
Hello, Ruby. Long time.
Hi. Hello. Hi, Manoj. I think long time, huh?
Same as me.
So, any one of you, Manoj, Ruby, do you know about this data set MNIST?
No.
Manoj? So MNIST data set, if you just Google also, so this is about handwritten digits. Okay. Okay. So if you MNIST, you can see this. This is what it is.
Mm-hmm.
Okay. And looking at handwritten, we have to predict. And this is what Lekun, the guy Jan Lekun, who is, I think, right now at Microsoft or Google, I don't know, but he is the father, considered the father of deep learning, right? So, and this is a kind of hello world of deep learning, this data set. Okay. Modified national student. uh, Machine learning, we have Iris and Titanic, right? That is, this is same for deep learning. Okay. So in this data set, you have lots of these digits handwritten, right? And you have example of it data, and then there is so guys, one thing, my son is also joining this. Mahib, no, I want you to be active in it and just say hi. Hello. Hello, and he is also sort of listening to us on earphone. And I'll also sort of be explaining sort of deep learning to a 9-year old kind of, when we talk about it.
Oh,
Okay, I think.
awesome. Hello.
Hello.
What's your name? They're asking.
My name is Mahip.
Mahip. Mahipal Mahip. Yes. Manoj uncle is asking you. How are you? He's asking how are you.
I'm fine.
How are you?
How are you?
Okay. He is 9 years old. We are homeschooling him, and yeah, he is sort of, he probably will give fifth class exam next year. No, actually, after this thing pandemic, and I took a break for 1 year to teach in schools. I took a break from corporate data science career. I taught in village schools and everything, so I got some insights. And then during pandemic, there was a lot of, what you say, screen time. Kids were attending, and their vision was getting corrupted, right? And their sitting posture, so everything was online, right? So I took him out of school, and then we started talking to him, and he started learning, and we liked that. He also liked, me teaching him, and then Ravina, can we mute? Great. So let's start. So this data set is, like we see, MNIST is your Modified National Institute of Standard and Technology database. Uh, you have a lot of handwritten digits. So this is trained. This is sort of images, right? And then their labels. Okay. And how do you get this data set? So you see the window right now. I am doing it in Colab. Colab is your Python notebook on Google Collaboratory, right? Because I couldn't load Keras on my local system, so I thought of doing it in Colab, right? So you can ask me about the environmental setup and whatever setup I have done right now. So what I've done is I have from Keras datasets I have imported this MNIST, right? And this is the command I have given, right? Let me just comment it out. So what we will do. Uh, Manoj, is that I will keep loading this Python notebook at my GitHub uh, link, and we can share that, and people can download from there. Okay. Yeah. Let me, downloading Kira's downloading data set. Yeah, from Keras.datasets, I have imported MNIST. MNIST data set. Okay. And so what I've done is MNIST load data, and this is how I have got sort of assigned variable. These are tuples, right? Tuples are the way of sort of assigning data, and this is train images and train labels, test images and test label. Okay, and you see that you have these many images. Ones, tens, 100,000, 10,000, 100,000, million, 10 million, millions, 11 million something. Okay. Yeah. So it could be what, a second or what? This could be KB bytes or something, right? It could be bytes. Then it's bytes. Yeah, it's only 60,000. You're right. 60,000 images in training, right? And let's test also. We'll see. Right. As I'm running this code, it takes some time. It should have done it already, but yes. Good that I did this before starting. Otherwise, it would 10 minutes. So, So this. So 1 second. What are you saying, Manoj? Come again. I could. Hmm. So you just want me to explain and not sort of run the stuff, right? Yes, yes. But it's not very difficult. Okay, so it's not taking time. So there's 60,000 images, right? And 10,000 images. And what is 28 by 28? Manoj would know, right? Yes, this is pixel size, right? And to show you, I have just sort of, uh, uh, taken one pixel, one image, and you can see it in a very big format that it is handwritten, but because it is stretched, it is showing you in bigger. It would be very small, probably like this much shape, right? So right, so uh, go ahead. It- uh, Anyone takes a guess what it could be?
It's a numerical 5.
Yeah, it's 5. Yeah. Let's see that, it's good. So I have shown you train image 0, right? And let me just tell you what is label of it, right? You can see that I have done, I have got two of them. I have train labels and train images. So this is the first image I have. So how do you access, just for everyone, and also Mahib, how do you access anything in Python is it starts with 0. In normal life, things start with what? 1, right? But in Python, everything starts with 0. So we call Python as a zero indexing language, right? Things start with 0. The first number is 0, not 1. But in natural world, everything starts with 1, right? So just like train images starts with 0, let's see what is the label. Actually, the label is okay. I find it uninteresting, so he's leaving. He survived 10 minutes of it. Anyways, cool. So train images, and let's look at the label, which is what do you think it could be? 5, right? In an ideal world, it should be it should be 5, and it is label, right? No, what is spelling? I have spelling labels. S is there, okay? 5, okay, right? And I have done this 10 images 1, but it should be. Let's see. It is in the book, but I'm exploring it more than the book, probably, right? Because we would want to know more. Okay, okay. But it is good that we are sort of exploring in this way rather than, so you can see, if I sort of look at this image, not so what I have done here is I have plotted this image. Okay, in we have showed this image, right? But actually, if you look at it, everything is stored in as an array, right? And this is like 28 by 28 array, right? So this is this image. You would see that 0 is the first image. 0 is the first image. Yes, yes, yes. PLT is for matplotlib. Hmm. Let me write also, comment on it. Hmm. Okay. And then actually I think we can code in GitHub also directly. We will see if that is possible anyway. Cool. So this is the image, right? You would see that top and bottom are almost right. First 5 metrics and last probably 3 are almost all 0, blank, right? And that's what you get here also. Satish Panimalar, Ruby, Revti.
No, Ji. Like yesterday, Manoj explained the pixels.
Hmm.
Just check. We have the three matrix for each. I mean, three values for each RGB. How can we understand that one? Vinay, can
No,
you?
this is one. This is two-dimensional. Sorry, not only two-dimensional. This is actually not RGB. You will see that here it is color, but actually it is not RGB.
Oh, it's not RGB. Then how it
No,
is?
it's a grayscale actually. It is showing it as an image, but this is not how it is. Originally, it is grayscale.
Grayscale, but it should be from black to white to the shades, no? But this
Yeah,
one
yeah.
is a blue, yellow, and green, so I think it's an RGB, right? Just go to
I mean, still,
that pixel, I mean the matrix down in that code,
ah,
in that collab, no? Yeah,
hmm,
that matrix you are showing the matrix, no? Yeah, this is
it's two only.
so this is how
It's
many dimensions? See, it's a two array. So there's one. What is this?
yeah, it's a two-dimensional.
So each two dimension one.
There's no tuple is not callable. Anyways,
Okay, we will explore
it's
it again. Maybe we'll.
you can explore it, but actually it's a grayscale.
Yeah, but
I mean,
yeah, I don't know. That one grace is showing this values like a grayscale 0 to. I think red is not there. Yeah, yeah. So that's why the two arrays are here. See, can you see that array? In the array we can see two arrays, no?
ah,
It's an array of array. So red is not there.
ah.
Yeah, green and yellow is there. That's why two arrays are there. Red is missing. That's why three arrays are not there. You understand that? So this array, if you see, it's an array of array, right?
No, Manoj, this is first row. This is second row. This is first 28. This is second 28. This is third 28. First row, second row, third row, fourth row, fifth row. This is like this.
Okay, okay. Yeah. Anyway, let me explore it. Why is it here? I'll try to find it something. Yeah.
Why matplotlib?
Okay, let's continue. Yeah.
One second. Why matplotlib showing showing color? Let's see why. Hmm? So why the image comes colored when I don't explicit set see ma'am.
Yeah, yeah. Matplotlib is why images are coming up. Yeah, this is the question, right? Yeah, right. Yeah.
Yeah.
They have one value for what is it?
The default color map in matplotlib is viridis. This is color map with colors, and for most data you want to plot a colorful representation is considered useful.
Oh, okay, okay. So maybe it's a
By
grayscale.
default, uh, it is grayscale, but matplotlib default color map is viridis,
Okay, maybe
and because of that, it shows that.
just to give us some colorful something. Yeah. Okay.
Yes, yes.
Oh, thanks, Vinay. Yeah.
We can, yeah, that is the case, or we can do this matplotlib SPLT cmap is equal to great.
Yeah, it's a good information that you found this.
it's always good. 1 second, na? Grays. It's probably grays. Okay.
GRAY.
GRE?
GRAY. Great. That's what the option says.
Acha, acha, acha. This also works? Or you want me to do this? No, this is not an. Acha, GRY, small one, na? Small, okay. small one. Ha. Okay.
Okay, fine.
Cool. So we have understood this. And similarly, same thing for test also. Okay. Test also will have same. So shall we move ahead? Questions till now, guys? Can ask questions. If everything is fine, we will go to the next step. Guys, tell me everything.
Yeah.
Okay. So guys, next what we will do is we will feed this data, this training data uh, to our model. Okay. And this model will check with test data. After it outputs, it will check with test data. And when it does that, it will see if it can reduce that error. We will talk more about how it does that. It goes to feed forward and then backward propagation. There are two uh, uh, sort of algorithm which goes like this, and one pass of that sort of feed forward and backward propagation creates one epoch, right?
Yeah, yeah. Yeah, yeah, if it's greater than 0 only, it will give the output. Otherwise, it will give as a 0 if it's negative. Yeah. The sigmoid, right?
Sigmoid. When we have multi-classification, then we need to go with softmax.
And there is one. And there is one tan h, no? It's a -1 to +1, I guess so. Yeah, okay, okay.
quick question, like how come we got 5 to 12 nodes in the first layer, 10th layer?
Yeah, I think it's like 2 raised to power. How much is 512?
2 raised to 9, no? 2 raised to 8 is 256. 2 raised to 9 is 512.
9,
Yeah.
60.
9, 9, 9, right?
Yeah, yeah.
9. Maybe that is the reason. 2 raised to power 9.
You know, why the 9 came? That is the question, right?
Yeah.
Yeah, I think why the 9 came
No,
is
they just took it maybe. Or it's mentioned there something. Otherwise,
generally this is, I think this is because it is start, he has just taken one number which sort of makes sense that there are uh, this much sort of input. 28 into 28 would be somewhere like around 800, right? So
hmm.
7, 8.
huh?
784.
Yeah, 74. So just less than that it has taken,
No,
right?
maybe they have explained something. Maybe before this or after this, they might have explained.
No. Before
No?
this, nothing explained.
Uh-huh.
Later we will see.
Okay. Okay.
Now we can just read. We can together do the reading now.
Yeah.
Okay.
If
So
somebody.
what is happening? Okay, and what are layers? So it's now he is explaining about the layers. So layers are nothing but data filters. Okay. So it extract representation, right? You can think of representation as learning some special thing about data. When something is given to you, and you think that it is linear, it is quadratic or something, the more sort of layer and the nodes in it, the more complex understanding or representation of data it can learn. Okay. We have two layers. One is your 512, another one is 10. 10 one is your outer one, right? There is an input layer also, right? That we are not considering, right? And these two layers are also called because every single node is connected to other node. It is fully connected, right? And as you know, it's softmax layer, which means it will return an array of 10 probability scores summing to 1. Right? Each score will be the probability that current digit belongs to one of our 10 digit classes. Okay, Manoj, so the question you were asking yesterday, each score will be the probability.
Each score will be the probability of the current digit image values. Yeah, yeah.
Okay.
But then they are using some extra something, and output is 1 and 0. That's what I.
That is easy, right? So you will maximum you will take as one, right? That you don't need to code in your, right? To you're getting why I'm saying that, Manoj, right? Because the main part is you're sort of forcing them between 0 to 1 and summing, making the sum equal to 1, right? The last part is
Yeah.
not sort of. Okay. Okay. Now there are three things which are important for training: a loss function, right? Your loss function would be how the network will be able to measure its performance on the training data. Are you hearing a lot of noise?
Yeah, there is much noise. Yeah, it's okay.
There is noise.
Yeah, yeah, there is a noise, but it's okay.
Okay. The younger one is shouting the chip. Okay. Okay. So loss function is when this network will predict something, right? And we have already given train label, so it will check between what it has predicted and what is the label actually is. Okay, sort of training error, right? A loss function will uh, take a tab, keep a tab on that. Okay, that is loss function. Come again?
So, loss function is to do the test on the training data. It's mentioned like that.
Loss function will just take a tab. I mean, it will look at the difference between what is predicted and what is already what is actual the true label.
For only the training data, right? While doing the training.
Only for the training data. Yes.
Yeah. Okay.
Okay. Optimizer is, so this is loss function will keep a check on it. Optimizer will use a loss function to sort of make sure that that error gets reduced. One second. Okay. So metrics to monitor during training and testing. Here we only care about accuracy. The fraction of errors there we are correctly classified.
So this matrix is for training and testing.
Whatever metrics we choose, we can have ROC, we can have F1, we can have your specificity, all these kind of things. Okay. So right now we are looking only at accuracy. Accuracy is how many are correctly specified divided by how many are there. The fraction of the images that are correctly classified. Okay. Okay. So this step was your network architecture, the last one which we did. Okay. Okay. Come again?
Nice name, I was saying. Name is good.
Network architecture. This is the compilation step. Okay, now it is getting compiled. And here, let me just write in network architecture.
Vinay, our hero has joined.
Hero is who?
Sudeep Das. Hi, Sudeep.
Hello, Sudeep. Okay. Hi.
Sudeep used to ask a lot of doubts and make it more interactive.
Yeah, actually I was busy. I could not get time to join. Okay, continue. Let me see. Then later I will talk.
Okay, we are going to the R2 book of the DL actually.
Okay.
It's more into like practice. So Vinay is taking some extra this codes and trying to show us how to do this stuff in practice.
Okay.
Yeah, Vinay, are you there?
Oh, sorry. I was speaking on mute. So, so optimizer is looking at your loss and your data, how to sort of get to reduce the error, right? And metrics is your accuracy. Okay. This is now the architecture is now the network is getting compiled. Okay, you can do it like this. You can do it like this. Let's do this like this. Okay. It's compiled. Okay. So optimizer is RMS prop, loss is categorical cross entropy, metric is accuracy, and as the other says, we will come to know about it later. So it's sort of we start doing things, and we will sort of understand it as it goes through. Okay. Come again, Manoj.
Loss is for the training set. We are finding the loss in the training set, and then
Yes.
the optimizer also in the training set, right?
Yes. 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 Test is not being included till now.
And metrics is something which is for the test and the training. Yeah.
No. Training only. Everything is on training till now.
Okay. This is also on the training only. Huh?
See, we have not given the data till now, Manoj. Just see. It can work on both. It can work on anywhere. It's in our mind that train on test data, right?
Okay.
We have not given the data till now. So it depends on us.
No, sorry. The loss function is actually on the training. No, it's not on the test, right? In the test, we are not looking the loss and all, right?
And let me see. Let us not get ahead of ourselves. Let us see. Okay. So this is compilation step till now. Things are clear till now. The data will get in, and it will look at the loss, and then it will try to optimize looking at loss, or reduce the loss. Right. This is also clear that what is optimization? Optimization is reducing the loss. Right. Okay. Now before training, we will pre-process the data. 1 second.
This compilation process, it is coming for data pre-processing for that only, or optimization, what you are talking regarding?
No. This is we are doing network. We created the architecture, and then how the model will get compiled. Pre-processing happens before all this.
Okay. During modeling, that time only this compilation optimization you are doing.
That is modeling.
Then this compilation steps, when it is coming?
Come again, Sudev.
This compilation actually during training the model, that time only compilation coming, or after that, after training, this compilation steps, whatever.
This is part of training.
Training only.
Yes. Okay. Now, what is the pre-processing? During the pre-processing of data, we will scale them all between 0 to 1 interval. Okay. So you can see that our training images, for instance, were stored in an array of shape 60,000, 28, 28, right? Of type with values in the 0 to 255 interval, right? 0 will be your, I think, all black here, as you can see, and 255 is all white.
Okay.
Okay. We transform it into a float 32 array of shape with values between 0 and 1. Right? There.
What is the float 32?
1 second. 1 second. Here we are. We transform it into we flatten it actually. We will see how it works. We will just look it also. So let's do this, okay? Because this is how your this will expect model will expect the data. Okay. This is pre-processing, preparing the image data. Shifting my place of इसका वो बंद कर दे. I was sitting on dining table and kids had started making a ruckus there. Okay. Yes. So preparing the image data, and this is how it is. Train images, reshape 60,000, and we will see what is this shape is. Okay. Now let's look at first. You remember your first? What was the first image? What was the digit? 5. Yes. Okay. Let's just see now. The first one is just one image. Okay. Can I plot it? Acha, you want to see the, okay, this one, like this. Okay. I doubt if you can, if now it shouldn't make any sense, right? Because it's no longer that shape, no. It's not into 28 by 28. Now it has been flattened. See, it's only one single now. One single array. It is not two-dimensional now. Right? Yes, yes. You remember first question? Question paper number 1, first question A. That is what happening there, no? Right? Yes. So that also was getting multiplied, right? Now if you look at size of it, So it's not int. So it is length actually, not size. Yes, and then if you look at length of it, $784.
It's 28 into 24. 28, yeah. 28 into
Yes. Great, right? So this is clear.
yeah. So for training, we need to flatten it and give it to the training, right?
Yeah. Otherwise, how will it work?
Yeah.
Every single sort of image in this flattened form will go, right, and it will 784. These are 784 points, right? It will all go in 512 nodes, hidden nodes.
So yeah, that is the problem now.
Okay, these every single one, 784 of them, 784, right, of will go to these 512 nodes, and they will interact there, right? There will be weights and biases there, right? And there will be one value which will be coming out of it. Okay, out of every single node. We will see if we can, see what is happening and how, what are the calculation, etc. We'll try to understand. So this is clear till now, right?
Yeah, yeah. So the second line, the train images is the train images dot as type 432 divided by 255. What does that mean?
255 is making sure them they are between 0 and 1. We have between 0 and 255, right? That values.
Yeah, okay.
Grayscale value 0 is all black, 255 is all white.
Yeah, I am trying to understand what this command mean. Train images dot as type bracket is float divided by
Ah.
255. So train images dot as type. So it is converting.
A question, one question actually, why they are taking only prototype only, floor 32?
What should be the other type? What should be
No,
the
just one. No, why? Just what actually, this is all the time float I am seeing, but double and anything else, integer, anything can be taken. No, what is the reason?
No, I don't think Python has that. Like how? See, okay, tell me if it takes integer, what would be the issue?
Then integer will be
We can
0 and 1. You can take
no,
0
no.
and 1.
Yeah. So the problem is like you can't have decimals if you go with integer. Uh, so that's why we are converting that to float.
Ah,
Yeah, that's why we
that's
are
okay.
dividing.
A decimal point we are getting using float, but double if you take,
Python does not have double.
Yeah.
Okay.
Yeah. When I have one question, like why are we reshaping to 60,000?
60,000 are there. 60,000 images are already there. We are only doing reshaping here. We are flattening them.
Okay, 60,000 training images and just 10,000 test images. Oh, okay, just a split.
Yes.
Okay.
Okay, 28 into 28. Instead of 28 comma 28, which was two-dimensional array, now you have a single dimensional array. 788. You have flattened.
Yeah, this is called flattening. But I was
Hmm.
thinking how this flattening can help us. Yeah, it's a high level of something we need to understand. Yeah, how the
So we have some. I think let's keep it. I think in some time it will go away meeting.
Right, right.
You want to stretch it, Manoj?
What do you think? You can stretch it, or otherwise we will stop it. It's up to you. Yeah.
No, let's sort of be a bit disciplined about it. Let's keep it for 1 hour every.
Okay.
We can do it in 3-4 days,
Okay. Yeah.
right? Yeah.
That's it.
You will be taking every week, right? Weekly once, no?
Yeah, let's do it weekly once. That is also good. Or twice a week. We will see. We will talk.
I mean, it's up to you. Yeah. If you think you can do it weekly more than once, it's up to you. I mean, I'm not forcing, but at least weekly once is good. Yeah. Minimum. Yeah.
Okay.
If more than once is good. Yeah. If it's possible for you. Then I think
Okay.
it's a good introduction today. Yeah. What do you guys think? Panmula,
You are
Devan?
asking why we are flattening them, right?
Yeah.
So this will get clear, Manoj. But think now with flattening, you have one value, 784 values each, sort of going these 784 values going to different nodes, 512 nodes, right?
Yeah. But my question is like,
If
unless
if you don't flatten it,
yeah.
if you don't flatten it, how will it, if it how will you think of it?